So in this video, let's discuss how to write a Gazebo world plugin. Okay. So what we are basically going to do is this. We are going to publish on this factory topic. This topic helps us to spawn models on Gazebo. Okay. So we are going to publish on this topic and we'll see how to do that using the world plugin. So this is the package name is world plugin and I have opened it on Visual Studio Code. How to open it? Just go on over here and open folder, and it will open one more, and just locate your folder from here. Now something like this will open up. Now this is the code. The major important thing before discussing the code is, let me show you something on the catchkin mix. So over here, first one is the project name is, that's the simple thing, but you have to add this line specially for this Gazebo plugin so that it can search for the Gazebo thing. Okay. Now there are some dependencies: Gazebo plugin dependency, Gazebo ROS dependency, because we are going to use ROS as well in the future, and ROS CPP. We use this C++. Okay, so that's this dependency. Then this is simple. Now this is also for Gazebo. I have written everything within the comments. Okay, so these three lines are also very important. So whenever you define this, so what all things needs to be there, that I have written over here. So this all needs to be there, like Gazebo needs to be there, this all libraries needs to be there. Now after that, it's just compiling as we do in any other C++ file. You might be knowing it from ROS already. So it's just that adding library, then target library. Now the other important thing is within this Gazebo world. So within this world, there is Gazebo world, and it's very important to know where you place your plugin. So because our plugin is a world plugin, so it is placed within this world scope. Okay, so that's why I placed within this world scope. So that's also very important where you place your plugin. So you have to be careful with this, because I will talk in just 1-2 minutes that there are world pointers that is going to point. So it's very important that you place it on the right place. Okay, now this is just going to launch the simple thing. It's going to launch this plugin. Okay, now let me firstly build this. So I am inside this tutorial workspace, the one I have created, and now I've sourced my terminal because there are so many workspace, so I generally source it like this. Now let me make skin is going to build up, going to take some time. Okay, so let it be. Now let's discuss this code within this time. Whenever you write any C++ code, you include some, okay, so include some header files. So these are the header files. So gazebo.gazebo, obviously you need to import the Gazebo so that you can use the Gazebo classes and functions. Okay, now these two are very common, this Gazebo common, so this is also very common, and I have written why you are importing this. This is important because it will help us to inherit this world plugin. So this common is having the definition of this as well as many other things as well, and this we are going to use some part of physics as well. So that's why this physics is also important, and ignition is also important because we need to change the position of our model. Okay, so that's why this ignition math dot library important. I will talk about this, how I know this. Okay, so let's go inside this Gazebo namespace. I already told you. Now this, I've written this plugin and I have inherited the world plugin. So when I inherit this world plugin, so it must be there somewhere in the Gazebo API. Let me show you how you get this. Just go on Google and search Gazebo world class plugin and open the first link that comes over here. Now go inside this link and you will see this is defined within common. Okay, so that's why I included this common. So now you understood how I know these files. Now let's just move near this. Now you see this is the constructor, and I've also inherited this constructor. Okay, so this is the world plugin and this is the constructor, and I print inside this. Okay, now this is done. Now you will see one more thing that is called load. So you can understand from this that whenever our plugin load, it is going to load. The name suggests something like this, right? So you can see over here this load is there. And one more important thing about this load, this is a virtual function, pure virtual function. That means that a derived class do not have the definition of this, because is equals to 0 is there. So this is something from the concept of classes in C++. So I hope you know this. So virtual class is there, virtual void is there. So that's why we need to define this in our plugin. When we inherit, we have the definition of this. So that's why we have defined this. Okay. Now whenever you see any function in Gazebo, always note what is input parameters. So these are this input parameters. What are their types? So this is the type of physics world pointer world, and these are the input parameter. And what is it's returning? It's returning virtually void. So this is void. It's returning nothing. So you have to look like this. Whenever you look any of this, just look like this. So you will get a very clear understanding of this, how to define it. So that's what I've just copied it from the physics world pointer. This world is there. Now HDF. Now this is very important. These two things are very important. Why? Let me explain you this. So when you go inside this Gazebo world pointer, then these two pointer can point anything within our scope of world. What I mean by this is that, like, this pointer is defined over here, so it is having this world pointer with this load, and HDF also comes in with this. So this can point to anything within this world scope. This world is there now, so it can point within the world scope, anything within this world scope. Obviously we have to use the function to access those. So if you suppose if you want to point to this name, how will you do it? Let me show it to you. Okay, now let's go back to our code. So you see these two are there, and those are pointing anything within this. Now if I want to access this name, how I'll be doing this? I will use this world pointer dot name. So with this I can access the name of this, and it will give me the output as default. And how I know this function? Now this is also important. So when I said you to look at this, what is the type of this? So this is a physics type world pointer. Okay, so what you have to go back into your Gazebo API, and we'll see inside the physics. So we got a hint. So on this you have to go inside physics, then you have to search for this world pointer. Basically it will be having something within the world. Okay, now let's just go down, down. You will get inside this world. So see how I use the namespace to search something on Gazebo API, right? I use this physics, then this world pointer. Okay, so I'm inside this world pointer. You will find it somewhere within this name. You can see this name. So this is the function, and it's returning string. Get the name of the world. If you go inside this, it's returning name constant. It's get the name of the world. From here this came up. So now you understood that with these pointers we can point to anything within this scope, anything within the scope of this, provided that we know which function to use. Same way for HDF as well. Right now there is no HDF for this, but in future coming videos you will understand this in more clarity, that we'll be using this pointer to point to our HDF things. Okay, so that's very important. Now next thing, as we want to publish onto this factory topic, right, that we saw, that I told you right now, and our this is built already. Now as I told you, we need to publish on this factory. So what we have to do to publish anything on Gazebo, there is something called transport. So now how will search this transport? We'll again go back on APIs, Gazebo APIs, and we'll go inside this transport. We are again using the namespace concept to know this. And now inside the node, we'll go inside this node, right? We'll go inside this node. Inside this node, can you get the function that I've defined? An ODE node. So this is the node class, and this is node. Okay, now this node is having what? So we have defined this node, and we have taken this new transport node. So basically we're making a new type of transport node. Okay, so that's a way of initializing a class. Now we are initializing it with our world name, and where this initialization is there, once you come inside this node, then you will find this initialization part over here. installation over here. If you do not get this, then you can also ctrl F and find it over here, find it like this, that will also work out. And if you go down, you will get this. And what it is taking, it is taking just a space and string. So we have given string as our world name. Okay, so now I hope you understood this. And this is just that function that I told you, it's returning the world name to it. Okay, now after this is very much clear. Now advertise, so same thing you will find within this same node. Okay, now you understood how I'm using this namespace to search on this Gazebo API. So this is very important. Now we are searching for advertise. It's take what its input variable are, it's taking string, topic name, and these two are the, it's not necessary that you need to give this argument, that's why I have not given. And what it is returning, it is returning on this transport publisher. And one more thing to notice over here, this is a template library. Okay, so this is a template library. How you write this? So this is the transport publisher. How I know this? This is this because this is the return type, right? So that's why I've written this return type. Then this publisher name, I've given it a name, this variable a name, a local variable a name. Now I'm using this node to point to this. Then with this class, I'm able to access this advertise. So node is actually a class, right? So that's why I'm using node pointer to point to this member function. Okay, advertise is there, we are pointing to advertise. And because it is a template class, it is template class, we need to give it the message type. And how I know the message type? Now again, one of the last video I have told you how I know this. I've done like this. Now I know the factory message, that's why I've given message dot factory over here. So message is also one of the gazebo message type, messages and factory. And on one of the video I also told you how to search for this. Now let's search for this. Just go inside this other location, computer, user, load, then search gazebo 9, gazebo. Inside this messages, that why this colon message is there, that why this message scope resolution operator is there, because it's within the message folder, right? So that's basically you are grouping the things together. Okay, now search for this factory. From here you can get, and there is one more way how I got the first time. I would like to tell you that how I got to know this is actually when I right click on this. This is a function that we have defined. Now the this publisher is defined, so we'll be publishing on this, right? So now to publish, as we do in ROS, you know how we do it, we make a message and we input all the things on it. So we have defined this message type of factory as message. Okay, now what will be going to do over here, we need to set hdf file name. For the first time, how I discovered your file location, you know, I just right click on this Visual Studio Code and I go to the definition. Now you can see this location. You see, for the first time I came to know that it's within my computer. This is how I discovered for the first time. Okay, so this is how I know this. So this Visual Studio Code is actually very helpful for knowing the things like this. Now this is defined, that hdf file name. So now let's go on to this. Now open it with a text editor to show you what it can take in. This is optional, that means that not necessary that you have to give these values. Okay, so that's the meaning of this. You can directly publish this factory message as empty as well. That means because all are optional now. Here what we are setting the hdf file name. We are setting the hdf file name. And how I know this function, where it is being defined, let me show you that as well. So when you go on this factory pub is there. So this is basically Google photo buffer that I already told you. So this is having the source code name. So this is the code which is having the detail of this. Now we are going so deep on this, right? So this is having the detail of this. So set hdf file is somewhere within this. If I go down, then you can see over here set hdf. So this is set SDF. Just add attach a set before this and you can add this, so this becomes set SDF file name, set pose. So you'll see all those things over here. Set SDF file name, see, set SDF file name, it is taking the string. Okay, so this is how you come up with the things. Okay, now using this we are able to define our file name. So this is set SDF file name, it came from here. Now we have set a model table. So this model is actually there in Gazebo. If you have used Gazebo, then you know this model already there in Gazebo. So directly I use this to access this the normal way. Okay, so this is how you set the file name. But one more thing, if you notice over here, these are all string, right? So this is a string, this is a string, but this is not a string. So how you set the string is very easy. When you go on this photo buffer, you can just use a message like this and put a dot, and you can use is this is a class, right? So this is a class, and putting a dot you can use it member function. So that's what we have done over here. But with this is pose and it is defined within this photo buffer, then it makes it a complicated process. Then how are we going to set this value of pose? Now here comes something that Gazebo has set to define it very easily. Let me first show you. There is something called you see, yeah, over here you can see over here constant Gazebo pose. This is mutable pose, and what it is returning, it's returning a pointer like this, it's returning a pointer. Okay, so this is a pointer, you can see over here, this is returning a mutable pose. Now Gazebo has a way to convert this message, this photo buffer message, to Gazebo message using what? Ignition mathematics. Let me show you where this set is firstly defined now. So this messages is there, so this is somewhere we have to search within the messages in Gazebo API. You go on Gazebo API, search within this messages. Within this messages, if you go down and down, you will see this set. If I go more down on this you will see this set. So what we want to set, so we want to set the pose. So this is the pose, so it's taking the pointer, and where from this pointer will be coming? This pointer will be coming from this mutable pose. So this is a pointer. Okay, so this pointer will be coming from here, and then we need to give this constant ignition math pose. So let's search this ignition math pose. Okay, ignition math pose. When you go inside this class, that's obviously written by the developer of Open Robotics. So when you go on this class, you see you have to include this to use this. That's why I've included this one. That's why this is being included over here. Pose 3, you can use this to import X, Y, Z and role pitch here. Okay, so from where this part will come, this ignition math, how we'll be using this pose 3 messages to import this. Now let's combine everything over here and you will see this. So this message mutable pose, this is a pointer, and ignition math pose 3D, that basically define over here, and using this we can define this X, Y, Z position and roll pitch here. Okay, so this is all 0. So I hope from here to here you got everything. I go into so deep so that you will have a clear understanding and you will understand how to write your own plugins. Until that happens, then what is the benefit? Until you understand that part, then you are not able to write your own plugin, then what is the benefit of all this, right? So that's why I go in so deep on this. Although video is getting a little bit lengthier, but I know it will be very helpful for you to understand this thing in so much of depth. Now what we are doing, we are just publishing this. So we are using this publisher, right, that we have defined over here. This is very similar to the ROS publisher, you remember. So we'll using this publisher, another function on it, and we are publishing this message that we have defined over here. We have set all the values of it. We have set the hdf file name and we have set it position. Now we are publishing on it. So now this is done. So you learn the world plugin, how to publish on it. Now after this is done, there are other two methods we'll discuss in a short while, but now the last thing is you have to register this plugin within this Gazebo register world plugin. So that's what I've registered my class. Was the class I've registered my class. Okay, now this is done. Now let's try it. Okay, now let's try it. Our plugin was built and it is stored at this location, and to access this in Gazebo world we have used this name. So this name matches with this. Look, this name matches. That's why we given live world Gazebo plugin. And if you saw in this CMake, this was defined like this, and you can change the name of it whatever you wish to, and lib will be added in front of it. Okay, now let's launch this file. And before I launch it, where you'll get find this code entirely on this is on the link, GitHub link. When you open this, okay, now how to launch this, I've already given the command for it. If you do not know, then just go over here, just let's press it and launch. Now see, this world name is that we have printed. Remember, this world name is getting us the default. This line of code over here, this is the first line of code where it says Gazebo plugin created, and the next line of code, world name, we have defined it world, and it is accessing this name of default, right? So you can see on this terminal, this is created. Now this is accessing the world name called default. Now our plugin is ready. Now see, is our model got spawned? So yeah, our model is spawned over here. This model this is present within this location, and it has taken that model from there. I hope you understood everything inside this plugin very clearly, very clear. Now one more thing, if you want to add some other file except this table, then you have to make a model. Okay, so I know you might be knowing from this. Now it has to be there within your package.xml. You have to export it like this. Okay, then you can do this. Now let's get back to here. Now this was the method number 1. Although that's name of this is different, sequence is different when you follow the actual tutorial of this official tutorial. But for here, now there is one other method other than just publishing on this. Rather than using this publishing method, like publishing on the topic that I show you, on publishing on this topic, what we are going to use is we are going to use the method, and where it is coming from, world pointer, using the world pointer. Now see, we are using this function, but what's then it means it's there within some physics world. We'll again go back on this, again go on physics. Now I know you understood this. Go inside the world, it's here, go inside the world. Now within the world, what's the name inside that model? Inserting a model from HDF, insert model file, insert model HDF. So these are the two techniques that we are now going to run. So this is the technique number 2. Okay, insert model file HDF. So same way we have inserted a cylinder, and where the cylinder is coming from, this cylinder is defined in this. You see, this is defined within this, that I have defined it over here. So this is the other method of using this, and where we found it within this, that, and the third method. Let me quickly build the plugin. It takes some time to build it. Okay, so it's building. Let me check I've properly commented all the things. Yeah, so everything is same, just I've added one on this. Now let's launch it. Now see, this random position is assigned by this as per the model it's defined within this model, right? So this is how it is imported. Now you learn the method number 2. Now let's similarly see the method number 3 as well. Now let me comment this out. Just let's uncomment this entire part over here. Okay, now what this method does is this basically create a HDF file. HDF file we have defined a hdf like we do in a model. So we have defined this hdf, and its name is sphere, and its link name is link, and pose is defined, collision is defined, everything is defined on this, and we are going to import this. And where you will find the definition of this I have given on my tutorial page. Okay, now you can get this by directly clicking on somewhere on this, go to definition, you will get it within user include hdf6, and you can read this. So basically that's setting set from string. So whatever is there, it is setting this from the string. So we have defined a hdf. Now we have used this hdf and we set the string set from string, and we have defined everything on this. So this is a hdf we have created, and inside this we have used a string to define everything, and this make it change to go to next line. So you will see everywhere inside this model is defined. Once the model is defined, understand how this is there within this html format. I think you might have used this file before. So this is within this how it is being defined. So this is basically something that you might have learned in ROS before. Now there is concept of GetElement, GetAttribute. These are also very important. You will see this, you will be using heavily on this. So GetElement is there. So GetElement tells you get the element whose name is model. Okay, so which element name is model over here? This is the model name over here. This is the name, right? This model name, we have imported this model. Now we have created a pointer that points to this model, and we have stored over here. So this pointer, right? We have stored this pointer over here. Now we want to set some string. Okay, so what we want to set it from the string, that we want to change the name of this sphere to what name? Unique sphere. Okay, we have changed the name. Which attribute we have changed? So this is basically the element name, and this is the attribute name. So that's why we have used get attribute function over here to access this, and these are all pointers. Okay, so these are all pointing one by one to this. To understand this, then it's very interesting. We have used this model pointer, then this pointer is pointing to this attribute name. Okay, so that's the meaning of this. Now this is using this pointer to change the name of the sphere. So we have made a pointer, and it's using this pointer we are accessing everything inside this. So this format is very much helpful, and we'll be using this a lot. Get element and get attribute to get hdf file like this. Now we are just using the function that I just told you. That's within this class is there, insert model hdf. Okay, so we are using this function, inserting a model using a hdf. Okay, so we're using this, and we have inserted the model. We inserted this, what we have defined, we have inserted this. So this is the third method. First one was publishing on the topic, second was inserting model file name, and third is inserting model hdf. We need to again build our, so every time you make some changes on your plugin, you have to build it. But if you made any changes on your world or launch file, then you do not need to build this. I hope you know this from us. Okay, now this is registered. Now let's play again this. Okay, now you will see a sphere is inserted. Okay, you can see this sphere is inserted, right? So this is how this thing, and I hope that you understood everything, every line of this code in very much depth. If you still have some doubt, then just comment down below. Okay, and one more thing, if you go on this model, this name is got changed to unique sphere, which earlier we named it as sphere, but using this we changed this name. Okay, so that's it in this video. It's a long video, and I hope you enjoyed this video.